Hi, today we're going to take a look at finding a scatter plot and then finding the best fit line between two variables. We're going to look at volume and mass and see how they're related, see if they're linearly related. And I'm going to do it with two different methods. The first method is going to be Microsoft Excel, an electronic spreadsheet. You may have Microsoft Excel on your computer, probably you do. There are some other very good electronic spreadsheets out there. They work in a similar way, but some of the commands might be slightly different. The second method we're going to use is using a TI-80 something graphing calculator, using regression analysis techniques there and the list manager feature. So first of all, with Excel, let's say we had this data sheet and we wanted to find out what is the relationship between volume and mass for this information. Well, let's put it into Excel here. I'm going to actually make a heading here for diameter. That's the first thing that we have. I'll make another heading for length, and I'll make another heading for mass. And then I'm going to put the data in. It's 0.5 inches. I'll just put 0.5. Excel will be happy with that. And since the diameter doesn't change, I'm just going to use my fill tool. I'm going to move my cursor down until it turns into a solid colored plus sign, and I'm going to haul it down here until I've got all 5 data points in place, because there were 5 samples here. The lengths are going to be different, so I'll have to key those in individually. 15.3 was the first one, 9.2 was the next one, 6.0 it says, 2.0, and 10.4. Microsoft Excel is ignoring the zeros. The mass in grams is also listed here. The first one was 27.73 grams. Next one, 16.55, so I put that in. 10.58, 3.53, and then the last one is 18.83 grams. So now with this data in place, I want to calculate volume from the diameter and the length, and then I also want to find the relationship between mass and volume graphically. Well, the volume is going to be the area times the length. For a circle, this copper rod is circular in cross-section. Area is going to be equal to pi times the radius squared. So maybe I'll just find the radius first. Make a column here that says radius. And then I'm going to have Excel figure this out for me by just dividing the diameter in half. You can make a formula in Excel by hitting the equal sign. That tells Excel what comes after this is a formula, not data. And I'm just going to go over with my mouse and point to diameter. Then I'm going to hit divide by the slash, and then 2. Dividing the diameter in 2 should give me my radius. When I hit enter, sure enough it did, 0.25. Well, I want to do that for all of my samples, so I'll pull this down and my radius shows up there. So now I'll get my area. Make another heading for that. Area is also going to be calculated with a formula. So equal sign starts that out. It's pi times radius squared. Well, I can put 3.14 in if I wanted to, but Microsoft Excel recognizes pi with a set of parentheses as pi. So I'll just type in pi parentheses times, I'll point to the radius, and then I'll do a hat 2 to square it. So there's my area. I want all these areas, so again I'll fill down and it'll give me all my areas. Now I'm ready to calculate volume. So I'll make a heading for that. Volume is going to be area times width. So my formula says area times, not width, but length. So there's area times length. I'll fill that down and have volumes for all of my samples. Okay, now to make a graph, I want to make a scatter plot. First thing I do is go Insert, Chart. An XY or a scatter plot is the thing I want, so I select it. There are a lot of options available. These aren't very useful for science. We want the one that doesn't have lines in it. So I'm going to click Next since that's been selected. At this point, Microsoft Excel assumes it knows what you want to do. We should not believe that assumption is correct. So we're going to backspace through this and get rid of that information and click on Series. I'm going to add a series. I'm not going to name it at this point, but I'm going to select the X values. This little icon here that looks like a spreadsheet, if I click that, it'll go back to the sheet that has my data. So I do that. And on the x-axis, I wanted to put volume. So I'll highlight these pieces of information. I click the other icon, and it goes back to my little wizard here. I'll do that for y values as well. Click the little spreadsheet icon. On the y, we want mass, so I'll highlight that, and click this little icon to go back to the spreadsheet. Now my data points are all in there. I click next. Now you can see it puts a little legend on there. You can take that off if you want to by clicking that. I think I'll leave it on. Titles. Well, I'm going to title this in a descriptive way. I'm going to say mass versus volume. On the x-axis, I had volume, and it was measured in cubic centimeters, so I'll say cc's. On the y-axis, I have mass. It was measured in grams. I'll click next now, and the next thing it's going to ask me is, do I want this to be a new sheet or just an object on top of this sheet? I'm going to click new sheet because it makes a bigger graph. Click finish. There's my graph. Now, here's what I do to add a regression line. Go up to the chart menu when I'm on a chart, and one of the options I'll get is add trend line. That's Excel's way of saying do regression. Linear, I want to see if this is a straight line, so I click that. There are other options for more advanced studies. This is based on what we call Series 1. That's our copper rod. If I go over to options here, one of the options I get is I can put the equation on the chart. Microsoft Excel will figure out what the best fit equation is, and I can just paste it right on the chart. If I select that. I can also display my R squared value, which will tell me is it a good fit or not. The closer it is to 1, the better the fit. The closer it is to 0, the poorer the fit. Once I click OK, there's my line. And you can see it's a very good fit, nearly perfect. And there's my equation. That's the slope, and there's the y-intercept. Now, let's try this with a graphing calculator. Well, this is a calculator that's familiar with to a lot of you. Probably a lot of you have this calculator. It's a TI-83 Plus screen, but almost all the TI-80-something calculators work exactly the same way. So let me give you an idea of how to get started. The first thing I want to do is make sure I have some lists available. So I'm going to click on my Stat button here, and then I'm going to click on option number 1, which is Edit. I have some lists here, but they're not all free. So I'm going to do that again. I'm going to go Stat, and then I'm going to hit option number 4, which is Clear List. And I'm going to clear all my lists. So I'll go second function, list 1, comma, second function, list 2, comma, second function, list 3, comma, second function, list 4, and so forth. Enter. They're done. Now when I go to my stat editor again, I can see that all these lists are clear. In list number 1, I'm going to put the diameter, and I'll just steal this off my Excel chart because it's right here. So I'll put in 0.05, and I don't get to cut and paste. Oops, 0.05 is wrong. I need to go 0.5, so just 0.5. And I can't fill this column, so I have to manually enter these all. 0.5, 0.5, 0.5, 0.5. So there are my 5 data points. List 2, I'm going to use to put my length data in. That was the next piece of information. So I get that off this column. 15.3, 15.3. Next one was 9.2, 6, 2. That's all in place. Well, the next thing I'm going to do, you can probably figure this out, is in list 3, I'm going to put the other piece of data, which was the mass. So I'll start to key those numbers in here. 27.73. Now I have all that data in place. Okay, I'm going to do the same thing basically that I did with Excel, except it's a little bit less user-friendly on a graphing calculator, but it still works pretty well. If I go up so that my cursor highlights the actual L4 here in list 4, I can make a formula there, like I did for Excel. So I want to populate into list 4 the radii of all these things. What I can do here is, when I'm in list 4, I can click second function, list 1, that's diameter, divide by 2, and that will put all my radii in there, 0.25. I just have to remember because L4 doesn't tell me what it is. In list 5, I'm going to calculate my areas. So I'll go up there, highlight the list, and make a formula. Pi, which is second function hat, times list 4, which now contains the radius, squared, I'll do hat 2, you can also use that key there. There are all my areas. List 6, I'm going to put the volume in here. So I'll highlight list 6 and make a formula for that. Well, area times volume is, area times length is volume. So the area is in list 5, so I'll go second function, list 5, times, and my length, I put that in list 2, if I recall correctly. And then I hit enter, there are all my volumes. Now here's how I plot with the graphing calculator. I'll go to my y equals button and just make sure that it's empty. If it isn't, clear things out of there. Then second function y equals puts me in a stat plot. I'll select one of my stat plots, the first one, number 1, by clicking 1. I want to turn it on, so when it's blinking on 1, I'll hit on. The type that I want is the type that's highlighted here, and that is the scatter plot. That's what I'm looking at. Now, what do I want on my x? My x-axis was going to go volume. Volume was in list 6, so I'll go second function L6, and then I'll go down here to y list. The y list was the mass. Well, that was in list 3, so section function 3 puts me list 3. I can select from 3 different marks. Most of the time that doesn't make much difference, and I'll hit enter. When I hit graph, well, there are my points. They don't show up very well, so I'll go zoom, and one of the options that it gives me is zoom stat, number 9. If I select that, it'll make my window just the right size to fit the data that was from my list. Now, regression. Again, I go to stat, but this time instead of edit, I'm going to go over and select the calc option. Among the calc options, one of them is linreg, which is linear regression. It's going to give me an equation of a line, ax plus b. I'll hit enter. Now, it wants 2 pieces of information from me, and 3 if I want some optional information to display. The first thing it wants to know is what's on the x-axis. Well, that was volume, list 6, so I'll go second function, L6. Then I hit a comma as a delimiter. The second thing it wants is it wants to know where is the y-axis data. Well, that was the mass, which was in list 3, so I go second function, list 3. Now, here's something else I can do. If I hit comma again, I can paste the equation for the line into one of my y equals equations. So I'll click variables, VARS, y variables, click enter for function, and then I can pick any of these. I'll just do y1, and it'll paste that equation into y1. Now, when I hit enter, it does a regression analysis and gives me the equation of the line. Y equals ax plus b. A is the slope. That's what the slope is. B is the y-intercept. That's what the y-intercept is. Now here's something else I can do. If I want more information like the r-squared value, I can get it. But I have to change something in my calculator. If I click second function 0, a catalog opens up. If I go down to the d's, I can find something called diagnostic on. If I just click enter and then enter again, it turns my diagnostics on. Now I'll do that same calculation over again. You don't have to do this anytime, every time. Once diagnostics are on, they're on. Enter. Now this time, in addition to the y equals ax plus b, the a and the b, I get an r-squared value and another value that not many people care about called r. You can see it's, again, it's a very good fit, and it's pretty much the same thing we got from Excel. When I hit graph, now not only do my points show up, but the line also shows up. That's how you do it. Excel or EI 80 something.